Hello, I'm Luca. For the hackathon, I've built QMesh. QMesh is a peer-to-peer LM inferencing network. So in today's world, the demand on the language models are increasing every single day. So we need the computational power to inference them, and the companies are building data centers around the world, and the demand is increasing every single day. So we need the more computational power, but at the same time, study shows that the personal computers and laptops are on idle about 50% of the time. Stanford study showed that the software engineers who have on average quite good laptops with a good resources, with good computational resources, are on idle about 50 to 60% of the time. This means that we in the world there's a huge demand on the computational power, but at the same time we are wasting the potentially very huge amount of computational power when we are letting our laptops and computers to be on idle. QMesh is a pure application which turns any computer into the node in the LM inferencing network. Think of it like instead of sending a request to the OpenAI or Anthropic, you send a request to the other nodes and you use them as inference. And when your computer is on idle, they are using your computer and you earn more credit. The system has three main components. One is a distributed system, which is built on Hyperswarm for nodes to find each other and collaborate. The second part is a Quark SDK, which lets us to run LLMs on the machine. And the third part is a contribution scoring system, which is which is like the scoring system that's adjusting fair usage of the inferencing. Like the more you contribute to the network, the more you the more computational power you can get. Now let me show you the demo. In QMesh, you are running either as a worker or as a consumer. We can run our application is a worker right now with a peer command. So it's running and the worker is ready for inference. And in the repository, I have examples of basic usage of the QMesh, and we can run some basic script. So now consumer is connecting to the network and sending the prompt to the worker and getting the results. So during this time, worker is updated with the scoring or update its score and broadcasted score to the network. Also broadcasted the worker status, which gives us the queue of the tasks. I mean, if the worker has items in the queue, the task goes to the another worker, gives us the system statistics, and which it also works the same way. If the computer is highly loaded, it goes to another peer, and so on. We also can see the leaderboard of the workers of the nodes who are top performance and who have more points. So this worker, which is running on this device, has a 21 points, which means that he can use 21 points to inference from others and to be on the priority list to be on the higher priority list. So there are some examples of how to use QMesh, and let's write some custom one. Initialize QMesh client and to the network. And we are now ready to send prompt. So the worker is running. So cluster is 4, and worker also gained some points based on that. So good part about routing. The good part is that routing is not happening randomly. It depends on the several factors. Like first top factor is the worker idle or not. We monitor QMesh is monitoring their processing power usage, like CPU, GPU, and memory. We also consider their scoring and prioritizing highest achievers. And for the future, maybe we will consider QMesh will consider some geographic location to distribute the requests across the workers.